Oh, good. We're live. Hey, guys. So this is the Mac and Cheese Show. Today we are joined by Sheil Choksi from the field engineering team here at Ascend. He's standing in for Mac. Sheil, would you like to introduce yourself?
Yeah, sure, definitely. Unfortunately, the Sheil and Cheese show doesn't have the same ring to it, but as Joe mentioned, coming in from the field engineering team, so done a lot of software engineering work, mainly with startups, some enterprises, and excited to kind of see what Joe's got today, a little bit deeper on the infrastructure side.
The naming scheme is a work in progress. Feel free to leave your comments in the comment section and subscribe. All right, so we're going to be talking about private data connectors today. Specifically, private data connectors involving hybrid cloud, and the end of it, a little love letter to Kubernetes. So just hopping right in, as I mentioned, Sheil's standing in for Mac today. But what are we actually going to talk about? So we're going to talk about where enterprise data lives, specifically, and what that actually means for a data company that is trying to process that data. We are going to talk about how you actually access customer data in all of these enterprise data security situations. What all goes into obtaining that access and managing it. So these are your various gateway options and what characteristics they all have. And then lastly, how does Kubernetes fit into all of this? Because it does. Trust me. So first off, where does enterprise data actually live? A little bit of context. So Ascend processes data by pulling data in from customer data sources and then processing it internally in the Ascend cloud environment. So what this means is that we do still need to actually get the customer data from wherever it lives, but then we just iterate internally. So customer data, it lives in the cloud in many cases. Oftentimes this will have public endpoints. Public endpoints are generally very easy to access. This is characteristic oftentimes of buckets and APIs. Buckets is often your data lake sort of situation. APIs can be your various apps you may be consuming from, or other vendors that a customer might be using may have an API they want us to consume from. The next piece is actually private endpoints, and this is where it gets really much more interesting. Typically over private endpoints, what you're dealing with is databases, oftentimes persistent queues like Kafka, or warehouses, your Snowflakes, your Redshifts, anything where you're having to go and send it load commands to go and pull in data from stuff. Where it gets a little bit more tricky, though, is when you actually get to on-prem. Many enterprises still have on-prem data. They still have data centers where they're trying to run their more, expensive workloads, for example. This is very similar to cloud by data source and access options. The difference is typically you're dealing with more legacy networking options to connect to these data sources. So how do you actually access this customer data? Frankly, it's actually a really simple story. For public endpoints, you need creds. Or you don't need creds if it's a fully public endpoint, but that effectively never happens. So you need credentials. Little aside, you do need to exchange the keys with the customer. We find Keybase works very well for this because you can just publish your PPG key, your public one, and then the customer encrypts whatever credentials that they want to send you. They shoot them to you by email or whatever. Because it's fully encrypted, you can just do that. You decrypt it and then use it. Private endpoints is the meat of the conversation, though. This ultimately is characterized by the same creds, because still need them, but also gateways and configuration. So that is, how do you get into the private network to access something, and how do you configure all of that and manage it? Getting a little further into these gateways. So what are the things that actually matter in your gateway selection? Off the bat, so we are a multi-cloud company, so we run in Azure, Amazon, and GCP. So for our use cases, cloud portability is really important. It is important that I can build something once, run it in any cloud. It is important that I can provision a connection for a customer in one cloud, and then still be able to move their environment to another cloud very easily, and still have all the connections work. This is one of our advantages as a provider. We can do this. Ease of setup. Ease of setup is very important, just frankly because we want to empower our customers as quickly as possible. So if it has an easy setup, that's good. IP agnosticism is part of this. So if your solution cares about the actual IP range of both sides of the connection, that makes it harder. Because oftentimes, we don't actually have really any strong opinions on our IP spaces, but customers do, because they're building up these big interconnected networks with all these IP ranges, and they maybe only have one specific one that you can use if you need to connect by VPN to them, for example. Scalability is important, sort of. It depends on the data source. So for things like data warehouses, you are typically actually often connecting by a public endpoint to the actual bucket, loading much data in, and then you're maybe sending a quick command over SSH, potentially to, say, a Redshift cluster, to say, just put a bunch of data in this bucket here, go load it. That doesn't take much. But other things like buckets, Kafka queues can potentially be higher throughput and require more scalability. The other piece of this, we actually only read in data once. Again, because we read it in once, we iterate internally. So we don't need to have, we require less throughput at a steady state than we do when we're doing a backfill, for example. Security. Security is actually relatively straightforward. We don't consider insecure solutions to be an option. So don't need to spend too much time on it. There is some range of security considerations in these different solutions, but they are all at some base level of what we consider to be secure. So let's jump into the meat of it. There are a few things here to talk about. One quick note before we jump in: multi-cloud doesn't mean portable. Multi-cloud just means that there is a solution in every cloud. Portable means that you can take the solution in one cloud, move it to another cloud, and it still works. Portable typically means that you're implementing on top of Kubernetes rather than on top of the actual just cloud resources. But I'm going to go from left to right here. So starting off with the SSH proxy. SSH proxy is multi-cloud. It is also portable. The SSH proxy does not care what hardware it is running on. It just needs a host name and a gateway and a final endpoint. So it's very easy to run. It is what we describe as a single service gateway. So because the SSH proxy is actually a full tunnel that forwards traffic directly from your local VPC all the way to the destination, if you need to expose another service, you actually need another gateway. One nice thing about this, you don't need to exchange any private keys. We can just give a public key to the customer. They pop it onto their bastion, and we're off to the races. Another nice characteristic of it is it is IP agnostic. Specifically, the only thing this depends on is namespace resolution locally, and everything kind of just works because the endpoint is resolving wherever it is, or sorry, the bastion is resolving the hostname of the endpoint, so you don't need to exchange any DNS record sharing either. On the whole, we consider this to be a very easy solution. But it is customer managed. So it depends on the customer keeping that actual gateway up. And it can potentially go down. Or sorry, they keep the bastion up, we keep the gateway up. So we like this for situations like sending commands to a data warehouse. I think it works great for that. Don't know if it would work for higher volume, like talking to a bucket. The VPN actually came in next. So this is another multi-cloud solution. It is also portable. One of the big differences first is it is multi-service. So where the SSH proxy represents a single service, a single connection all the way to some remote endpoint, the VPN is an actual network level connection. So you can route over it. You can discover services on the other side of it. It's a continuation of your network. You do have to exchange a private key. Technically, it's a pre-shared key, but you have to do that. It is IP exclusive-ish. It cares about the IP space of your cluster. But your cluster IP space is actually relatively easy to manage. The reason this is relevant is the IP space of your root network, so your actual cloud level network, if you need to change that, you need to destroy your cluster. You need to rebuild the entire environment, which is slow and just kind of annoying. Inside of your cluster, you can pretty much change that at runtime. Like not 100%, but you can mess with it with a much lighter impact on your operations. We generally consider this to be a hard solution. The actual work of setting it up with the customer typically involves someone very highly technical on their side. And it's just very hard to debug when it's not working right, because you just get oftentimes garbage on one side or the other. Again, this is another customer managed solution. In this case, it is particularly relevant to take into account what the VPN server is actually being used for. We can potentially hit it with quite a bit of traffic as we try to pull down the necessary data. It could be mistaken for a DOS attack as we're just going through normal operations. But if you have a customer that's, for example, using a VPN for their developers to access data sources and also wants to use that same one for us, it's maybe not the best way to do it. And that should be a conversation with the customer at that time.
Joe, on these kind of SSH proxies and VPNs, it seems like there does still need to be some exchange of information between the customers and the Ascend platform. Mm-hmm. What's a good way of doing that, especially like private key stuff for VPN?
So this would go back to Keybase, I would recommend. So Keybase is a nice solution where you can easily host a public key. You basically make a PPG key, publish it to Keybase. You can actually give someone just a nice URL that just goes to your user, which is associated with your public key. They drop some text into a box, encrypt it, they grab the blob that spits out, and then they just email that to you. It makes it very easy. In particular, it's good for oftentimes, frankly, you'll have someone in sales or support on a call. They need to do some key exchange, and they don't want to have to add someone to 1Password or to whatever. They just want to be able to say like, hey, just give me the key so I can go help you with this thing. And this works really well for that because they can literally just encrypt it, send it to you in Slack where you already both are, and then use it without it being compromised.
That makes sense. Help avoid that temptation of just tossing it over, right?
Yeah, security is about making security easy. It's not about making it perfect.
Okay, cool.
So the next big one here. So these last two are both cloud level options, and this is going to have some different characteristics. You'll typically see them be a little bit easier to manage at runtime, but more annoying to provision. VPC peering is the first of them. It is multi-cloud. Everyone has the ability to peer VPCs. It's just network peering at a cloud resource level. It is another multi-service solution, much like a VPN. The IP spaces do need to be different. There are no keys that are exchanged, which is nice. You just have to basically present a VPC peering request and then accept it on the other side. It is, but yeah, it is IP exclusive. So if someone wants to do VPC peering and you have the same IP range or an overlapping IP range, you do need to rebuild. It's relatively easy. Once you get it set up, it pretty much just sits there and just works. It is cloud managed, which means that it is basically no ops. It just goes.
I feel like there's something interesting there around it's relatively easy, and I noticed there's an asterisk here. Perhaps there's something interesting to dig into there.
Yeah, it's so it's actually something that I ran into at my previous job, where particularly in large enterprises, you can get a very polluted IP space just by utilizing chunks of it through these various services, and then you acquire companies, they have their own IP ranges, and what you end up with is it's very difficult to actually interconnect all of your necessary dependencies. So you can potentially, as you connect more things together, as a vendor, we're probably obligated to be the one to bounce around to a different IP range, being frank.
Yeah, like valuable, right?
The customer's paying us. And it's relatively easy for us to do. And if it's going to be a choice of them moving their stuff around versus us moving our stuff around, it's probably going to be us. So it's difficult to resolve a very thoroughly used IP space, and you can run into situations where customer wants to add in another network for access later in the game that happens to actually overlap with something you've been granted, and then you just need to get a lot of ducks in a row. At the end of the day.
So perhaps just a lot of setup and communication upfront, and then once it's all sorted and once the IP space has been dictated, then it's pretty easy.
Typically, once it's in place, you kind of just leave it. But there is always the opportunity for someone else to come in and say, hey, I'd love to use your product too.
Okay, fair enough.
So the last of these solutions is private endpoints. Private endpoints are, I think they're delightful because they actually address a lot of these issues that we see with VPC peering, where you can have a cloud level private endpoint where it's managed by the cloud, it's very high throughput. It is single service, which is a plus and minus. Is it plus because it is very granular? It allows you to have finer grained access management to some single endpoint rather than to just a network. But it's single service, so if you want to connect to a bunch of things, you need to make a connector per thing. Again, there are no keys to exchange because it's just basically making a connection request and then accepting it. And it's IP agnostic ish. Let's see, I think in Amazon it's fully IP agnostic because I believe that it's just an endpoint in your VPC. I believe in GCP it's actually managed by way of a peering connection to just a tiny, tiny little VPC. So you do need to do a little bit of IP space management there, but you can largely think of these as IP agnostic. I would describe it as hard-ish. I don't find these to be commonly used by a lot of people. I think they're a less well-known solution, but I think they're a really good solution when you can use them. They're cloud managed, so you have all those benefits as well. Go ahead.
I kind of want to poke a little bit about throughput, because I think it was one of the big criteria. And as you just kind of talked about, the private endpoints have great throughput. VPC peering, it sounds like similar. So everything kind of cloud managed has got this fantastic throughput. So when we're talking about like SSH proxy and VPN, are there solutions on the customer managed side that they can get their throughput up? Or do you typically see the recommendation moving towards these cloud managed solutions?
That's a really good question. I think that there are clustering and horizontally scaling solutions for VPNs, I think. So if you have something like that, that can be a good way of addressing this. As far as SSH proxy, you could probably figure out how to do. You could probably figure out how to do it with an SSH proxy. I don't know offhand of specific tools for this. The thing that you run into with each of SSH proxy and VPN is that they're actually both session-based. Mm-hmm. So if you, for example, have something that scales up and down, they're not entirely. So like private endpoints are typically backed by network load balancers. So you're typically just hitting effectively a forwarding rule. Mm-hmm. SSH proxies and VPN, there's more negotiation. So if you have a scaling event, you scale down, you may experience interruptions in some network requests. But there's probably something there. We haven't run into it yet. We have both of these solutions in the wild right now, the wild being production. And they both currently appear to work well enough.
Mm-hmm. I think, yeah, more of an interesting curiosity than anything. I think the point being, as you were talking about earlier, picking the right solution for your throughput requirements. So, maybe if you're issuing commands to a data warehouse, then SSH proxy, fantastic choice. Easy, it's going to work. But perhaps not pushing it to its limit if all of a sudden you are trying to get gigabytes a second out of it. So,
exactly.
Okay.
If anyone does know any solutions, please leave them in the comments section. But yeah, no, that's a great question. I'd be curious if there are any vendors that actually have solutions for either of those, because that'd be really interesting.
Yeah, and one last thing, just out of curiosity, you're kind of defining between multi-cloud and portable, and it sort of made me sort of also come up with a different definition of like, what about like multi-cloud and cross-cloud? So, just because every cloud has VPC peering doesn't necessarily mean you can join AWS VPC with, I don't know what Azure calls them, but some sort of Azure
virtual network.
Virtual network. Okay, yeah. Thank you. So just kind of wanted to double check my understanding there, and if you could provide any clarification.
Yeah. So so not portable. I technically didn't define that to mean not inter-cloud, but I think it happens to also mean that, or it happens to line up with that for these solutions. VPC peering and private endpoints are within a single cloud. Typically, when you're connecting to clouds, most of what I've seen is basically VPN solutions. There's a lot of tools for doing hybrid cloud, for connecting a cloud to an on-prem, often by hard fiber. And I think you'll see similar deals if you wanted to connect between two different clouds. It's not super mature today, as far as I'm aware.
Got it. No, super interesting. Thanks for all the clarifications.
Yeah. All right. So I mentioned a Kubernetes love letter. I touched a little bit on it earlier. Kubernetes-centric gateways are awesome. They're great. Why are they great? Glad you asked. First, they're fully cloud
I was wondering.
They're fully cloud portable. So getting into, we benefit a lot from Kubernetes because we are multi-cloud. We could not be multi-cloud without Kubernetes. It would not be feasible. It just wouldn't be feasible. So the fully cloud portable, I can write it one time. I can, build the deployment. It runs anywhere anywhere I can run a Kubernetes cluster. They are generally IP agnostic. Part of this, whether it is a host name level access or if it's actual IP routing, because it's on top of Kubernetes, and Kubernetes makes this easier to operate without having to be super destructive. You get a lot of operational advantages from that, and making things more composable and iterable. There is potential for finer-grained access control. So when you're dealing with containers, you have many potential workloads on any given virtual machine. And what that means is you lose the ability to reason about access at the machine level outside of, this cluster should have access to this endpoint. So you can start to get into some of the some of the security policies in Kubernetes can help you with this, to make sure that, for example, your worker pod, but not your API pod, can access this endpoint, because the API pod doesn't need to do that. It's not relevant. Are there downsides? Yeah, we have to operate it. I'm not against operating things, but if I don't need to operate something, I prefer not to. It's unnecessary work that someone else could do. Also, clouds are really good at this, and I'm fine at this. It's not my area of expertise. It's also just not it's not our core business. We process data. We happen to need to access things as part of that. And we try to reuse tools that exist already. This ends up affecting the throughput, availability, and scalability stories, which ultimately all take work to iterate on and refine as you are trying to make these solutions work really well. But at the end of the day, works really great. So running through what we covered, we walked through where enterprise data actually lives. It lives on the cloud. It sometimes will have public or private endpoints. It sometimes lives on on-prem data centers. You need to be able to actually access all of these different endpoints. Accessing it may involve gateways, and these gateways have lots of different considerations you should be thinking about as you think about using them. And frankly, try using Kubernetes for it. We think it works great. It solves our problems. And that's all we got. Thanks for watching, guys, and we'll see you next time.